Hello everyone, this is TLE Eliminators and I am Hariom Singh. Today we are going to discuss the CodeChef Starter 231. So let's get right into it. Problem A, double discount. Chef is craving a midnight snack and so decided to order some food on the Chef Eats app. There are N food items available on the Chef Eats app. The ith item has a cost of AI rupees and the tastiness BI. It is guaranteed that each AI is an even integer. Chef wants to buy exactly two food items from the app. Chef has a special offer ongoing. So the offer is whenever you order two items, the more expensive one will receive some discount. And how will that receive discount? It will be either 50% or 100 rupees, but that will be smaller of those, right? So this is the problem, and this illustrates how the discount is applied. And chef does not want to spend more than k rupees in total, including the discount. So our task is to find the maximum possible tastiness of buying two items while not exceeding a cost of k, right? The total tastiness is the sum of the tastiness, right? And we have constraints of the test cases are from 1 to 100. The value of n is pretty small, so they're expecting an order of n square or maybe order of n, some kind of that solution, right? Order of n square will work here, basically that, right? So let's just see what this problem is telling us. Okay, now look here, what is given to you? Given is an array or two arrays, right? And the array are of two types. Let's call them A and B, right? Array A and B. A denotes the cost of the ith item. And what does B denote? B denotes the tastiness, right? So each element or each dish that you have in your uh, chef app will have some cost assigned to it and will have some tastiness assigned to it, right? But our goal is that we have to choose exactly two items, right? Suppose we choose these two items. Suppose this one has a cost of, suppose this is item, let's say X, and this is item Y. Then what do we want? We want the total cost or the total price will be what? Cost of X plus cost of Y, right? And the total tastiness, this is what? Tastiness of X plus tastiness of Y. Sorry, let's write it here. Tastiness of Y, right? So this is the problem. What we have to do now is that suppose this item Y is more expensive than this item X, right? So what will happen now that you can apply a discount on item Y, right? So what is the rule for applying a discount? So when you want to apply a discount, what happens is, suppose your total initial given cost of some item is, let's say it is equal to D, right? So D is the, let's denote the cost with C, right? That would be optimum, right? Let me erase this and we will denote the cost of some item with C, right? So what happens is that you can either make this to C minus 100 or you can make this to C by 2, right? And take given that C is an even number. So C by 2 will also be not a fractional value, it will be a complete integer, right? So there are two possibilities, that either you decrease the amount that you're going to pay by 100 or you decrease it by C by 2, right? In both the cases. And what will happen is that you'll choose the maximum of them, right? Because in the problem, if you see here carefully, it has been told to you that one receives a discount to its price of either 50% or 100 rupees, right? Whichever is smaller. So the discount that you will be applying, that will be smaller. So that the final cost that you want will be larger, right? What I mean by that is, suppose the final cost after applying a discount, right? Suppose this is your final cost. This is what? This is cost minus discount, right? And they're saying that this discount will be minimum of what? 50% of the initial cost, right? Or it will be 100 rupees, right? So this will be minimum of them, right? So how can we write this in other form? We see this value is getting subtracted. The minimum is getting subtracted, so we can also write this as maximum of cost, where cost is what? Either your cost which is initially is given to C, that will be subtracted by 100, or it will be subtracted from C by 2, right? So your final cost will be maximum of C minus 100 or C by 2, right? So your final cost of each item will either be this or this. We'll take the maximum of them, right? So what we are told to do now is that we have to choose exactly 2 items from the shop, right? Such that what happens is that the total cost that you get after applying discount on the item which has the higher cost, right? Suppose if there are 2 items, one has a cost of 3, other one has a cost of 7, right? Then you apply the only 7, right? So this is the case, right? What you have to do now is that you have to choose the item among the total n items available to you, such that the total cost that you get after applying the discount is less than or equal to A, right? And for all the pair of items which satisfy the property, right, there will be many such pairs, right? For all the items which satisfy this inequality, we want to choose the one that has the maximum tastiness, right? This is the entire problem, and we have seen that this is how its mechanism is going to look like. So let's look at some test cases, then we'll see how to do it. Basically, this one you can just root for it because the constraints are really low. So let's just use some test case here. Let's use this test case, right? There are 2 arrays. The arrays are, let me move downwards. Let's use red. So the cost is 10, 8, and 14. While based in array, this is what 5 to 112, and maximum allowed price is equal to 16, right? So you cannot have a cost of more than 16. What is the most optimal answer here? We can choose any pair of 2 items, right? So just choose. Let's say so what we're going to do is brute force, right? So if we choose 10 and 2, right? This is the first case. If we choose 1 and 2, then what is the total? What is the items? They are 10 and 8. So what you can do now, you can just apply cost discount of either 100 or 10, but you have to choose the minimum of them, right? So your final cost will either be 10 minus 100 or 10 minus 10 by 2, as we already saw here. And what we have to do is that we have to take the max, right? As we saw here, where yeah, C minus 100 or C by 2, right? So your cost will be what? This will be negative, so definitely not feasible. 10 minus by 2, that is 5, right? So you'll get a cost of 5 for the item 10, right? And the another cost is 8. So your total cost will be, that will be what? 5 right? So this is 13. 16 lesser than 16? Yes. 13 is lesser than 16, so we can write these items, item 1 and 2. So this pair is valid, right? So if this pair is valid, then we can maximize our tastiness value with what? 5 and 2, right? Because we are able to take these two items, so we'll be able to take these two tastiness as well, right? So that'll be 5 plus 2, which is 7. So case where we have taken item 1 and 2, we'll get a cost of, we'll get a tastiness of total of 7, right? Let's just use another one. Let's say here we are brute forcing on item 2 and 3, right? So if you talk about item 2 and 3, what will happen? That the total cost is what? 8 and 14, right? So you have 8 and 14. What you can do now is that this has a total of 14, right? So which one is bigger? 14 is bigger. So you can plug down 14 only. So in third rounds, we can see that we'll have to choose the maximum of 14 this and 14 minus 14 by 2, right? We can always write it as 14 by 2 because x minus by 2 is actually equal to x. So let me write that. Right? We also write that property. So we can write this as 14 by 2. Right? Oh. So we can take max of this, and definitely this value will be lesser or negative, so this will come out to be 7, right? Now the cost of this is 7, so total cost is 7 plus 8, which is 15. 15 is lesser than 16, so we spare 2 and 3 is also fine. So the total taste is 2 plus 12, right? Tastiness is what? 2 plus 12, which is equal to 14, right? And now we see 14 is actually greater than 7, so the pair 2 3 is more optimal for us, right? Now the only pair left with us is the pair where we have the item 1 and item 3, right? Just choose item 1 and 3. In that case, you have 10 and 14, 5 and 12, right? 10 and 40, these are the costs, and 5 and 12, these are the estimates. So you can notice that 14 is larger value, right? So the discount will be applied on 14. So 14 will turn into what? This case is similar, so 14 will turn into 7, right? So the total, total cost will be what? 10 plus 7, and that is 17. And now you can notice that 17 is actually greater than this value given to us, right? This is greater than 17. So we cannot do anything. This is not a feasible choice. So we cannot choose these values 5 and 12, right? So this is not valid. So we have optimized till now that we have to take it on. So this value 14 and value 7. We have to compare them, and 40 is actually greater. So we use the pair 2 and 3, and the answer is 14 for this test. So let's see. Answer for this case is 14, as we already derived, and the optimal case is derived here also, right? So this problem was not about writing the code. If you get this idea, then it's just about implementation, right? There was nothing very large or very mathematical that you have to do, right? So let's look at the code. So instead of okay, one thing that we are given two arrays, right? And I do not really like to deal with two arrays. This is one of my personal wishes. So what I do is just create a pair of vectors, pair of pairs, sorry. So the first value of my each index will denote the cost, while the second value will denote the tastiness, right? So I took in the input. Then what I'm trying to do is that I'll just go over each pair, right? As we saw here. what I'm trying to do is just I'll go over each pair of elements, right, as we did here, right? We go over each pair and I'll calculate what the total cost that I need to buy that pair, and I'll compare that value with the value k, right? If this value that I get is lesser than k, then that pair is feasible. I'll maximize the total tastiness of that pair, right? So I iterate over all the pairs. I calculate the minimum of both of them and I calculate the maximum of both of them, right? And then my total cost will be what? The discount will be applied on on the maximum value, right? So that will be max minus 100 comma max by 2, the max value of both of them, and the minimum will be taken as it is, right? If this total cost is lesser than this value k, right, this value k, then we can maximize our answer, that is the total tastiness, with v of I dot second and v of g dot second, right? Dot second denotes the tastiness and dot first denotes what? The cost, right? And we can, in the end, we can just print our answer. So this was it. Pretty simple problem, and the time complexity for this one will be order of n square, because we are iterating over all the pairs, and rest of these operations are order of 1. Space will be order of n because we have not used anything else, just simple arrays, right? Okay. Moving to problem B, target temperature. Chef is preparing his restaurant kitchen for the day. There are n stoves in the kitchen. Initially, all the stoves have a temperature of 0. Every minute, the following will happen. First, chef can choose at most one stove and resets its temperature to 0 instantly. In particular, it is allowed to not reset the temperature of any stove if chef wishes to. Right? Then, the temperature of each stove will increase by 1. Note that it is allowed to reset the same stove multiple times in different minutes, of course. Chef thinks the ith stove is ready when its temperature is exactly Bi. Is it possible for chef to make his choices in such a way that all the n stoves are ready simultaneously? So you're given test cases and the value of n, which is the size of the array, and the stove final temperature. All of them are pretty normal constraints, 2e5, so they're expecting order of log n, or sorry, order of n log n, or order of n solution, right? So what we are told in this problem is that suppose you're given a stove. Suppose this one is a very large uh, tawa type of thing, right? And it will have multiple stoves on it, right? Suppose this one is stove 1, this one is stove 2, 3, and 5, right? Suppose these are the stoves. Then what will happen is that all of them are initially initialized to 0, right? All these values are zeros. So these are denotes the temperature of the stoves. Now, what we have to do here is that this is the stove's condition at the state t equals to 0, right? This is t equals to 0. What will happen is that at the step t equals to 1, the temperature of all of them will rise by 1. So this will become 1, 1, 1, 1, and 1. Now similarly, when t equals to 2, all of them will become 2, right? And this will become 2 and this will become 2. Now suppose at time t equals to 3, you decided that the stove 2 will move to the state 3, right? Sorry, move to the state 0. So you choose this stove and you make the temperature of this one to 0, right? So this will decrease to down to 0, right? And then what will happen is that all the stoves will increase their temperature by 1, right? So this will become 3. Now since this one was set to 0, it will become 1, right? This will become 1, sorry, 3, 3, and 3. Similarly, if you notice that if we talk about time t equals to 4, and now let's just say that this stove was decreased to 0, right? So what will happen? This will become 4 because this was 3 in the previous case. This will become 2 because it was 1. This will become 4, and since this was 0, it will become 1. and then this will become 4, right? So this is your array, right? You can have multiple such combinations of arrays that at each step you can choose at most one stove, or you can choose no stove to decrease its temperature to 0. And then what you have to do is that after performing some kind of operations, you have to tell whether this state is valid or not, right? What is meant by that is we are given the final state of the array, final state of the stove, and then you'll have to tell whether this stove is achievable or not, right? So this was one very observation based problem. So you first of all, if you see here carefully, that any stoves, right? So we talk about them. Suppose all of them were initially 0, right? Let's talk about 3 of them, right? This one was 0, this one was 0, and this one was also 0. So this is the state at t equals to 0. What will happen at t equals to 1? Or let's just add one more, right? Suppose I say that these two stoves are very special to me, right? The stove 1 and stove 2, they are special to me, and I will not reset them to 0, right? So what will happen is that they will keep increasing and increasing. So at the ith step, the temperature of them will be same, and they will be equal to the I, right? Now notice what I am saying is that suppose at time t equals to 1, all of them were 1. Now at time t equals to 2, both of them were 2. But at time t equals to 2, I decided that one of those, right, the stove 4 will decrease its temperature to 0, right? So what will happen now is that we can choose at most one stove at each point, right? So 2 will increase to 3. But since 2 was decreased to 0, this can only increase to 1, right? Now notice that if now at this step, at t equals to 2, both of these stoves had the same temperature. But at t equals to 3, this one is having 3 and this one is having 1, right? Now let's look at t equals to 4. Suppose this stove 2, this stove 3, this was decreased to 0, right? This was decreased to 0. Then in the final step, this will have 1 and this will have 2, right? Now notice that the stoves which are not special to me, at any point, right? The stoves which are not special to me, that is the stove 3 and stove 4, after some point, they are not having the same temperature, right? They are having 2 and 2, right? Which is equal to this one and this one. But if you perform an operation here, then one of them will increase by 1 and one of them will decrease, right? So since you made this one to 0, what happened is that in the final step it became 1, but the value which was only originally assigned to both of them, that is 2, one of them increased by that, but other one decreased, right? So what I mean by that is, if at any step we are having two stoves which have a temperature of x, and if we choose that this stove is going to decrease, then this stove will become 0, and this stove in the final step will become x plus, right? And initially it will convert to 1, right? And since this gap is created among them, that is the gap of x plus 1 and the gap of 1, right? Now these two stoves can never be equal in the final step, right? Because even in the worst case, you will just keep increasing them and this gap will remain constant. Or if you even try to, decrease this, right, in the final step, if suppose let's say the value of x was equal to 3, right? Both of them were equal to 3, right? In the next step, this became 4 and you choose to decrease them, so this will become 1, right? Now if you choose this 4 and make it equal to, let's say, 1 in the next case, right? You decrease it, then this will become 2. Now suppose 1 and 2 are here, so if this one is bigger, you choose to decrease it by 1, then this will become 1 and this will become 2. So these values will keep on oscillating among them and they will never be equal, right? So my claim is that the stoves which are not touched, right? The stoves which were, increasing their temperature as the time goes, and they were not touched or their temperature was never decreased, they will keep on increasing, and all the other stoves, their temperature will never be equal to one another, right? We can write this more. Uh, uh, we can write our claim, right? So my claim is all the stoves whose temperature is lesser than the max temperature will have distinct values, distinct and unique values, right? Because at any step, suppose you have an array of type, let's say 6, 6, and 11, 11, 11, right? And suppose 13, or maybe not, let's just not take 13. So suppose this was your array given to you, right? You can notice what would have happened here. These three stoves, they were never touched, right? So all of them increase their value to 11, right? In at time t equals to 11. But since these stoves are not equal to 11, it means that their temperature was at least decreased to 0 at least once, right? But you can notice that if even if this stove was decreased to 0 at some step, this stove will never be able to catch its value to 6, right? Either it would have become 7 at that step, then this would have become 1, right? Then this gap is 7 and 1 has appeared. Even if you decrease this to 1 in the next step, this will increase it to 2, right? And if you keep increasing them, this gap of 1 will remain, right? This gap of 1 will never be covered, right? Even if you have 1 and comma 2, you can either make this pair as 2 comma 1, right? You can make this pair as 3 comma 2, right? You can make this pair as 0, sorry, not 0, 1 comma 3, but this pair will never have the same value, right? Even if you touch them once, their value will never remain, they will never be able to catch each other, right? So our claim is that all those values which were touched at least once, their value can never be same, right? Or in another way, we can notice that we can just remove all the values of all the values which are having the max value from our array, and then whatever is remaining, that array should be unique, right? All the elements should be different from one another, right? So this was it. All you had to check in this problem, right? Maybe let me explain these test cases. So here you have 1 and comma 3, right? That is totally achievable, and that can be achieved pretty easily, as we saw here only. If you had let's say 0 comma 0, you can make this 1 comma 1, right? In the next step, you can make this 2 comma 2, and in the next step you can just choose any of the stoves to die out. Then this will become 0, and then it will become 1, right? So it will become 1 and this will become 3, right? So you'll have 1 comma 3. So 1 comma 3 is totally achievable. The answer is yes. In this case, 4 comma 4 comma 4, you did not touch anything, right? All of them were increased to 4 in one go. So the answer is definitely equal to yes. In this case, you can notice that these values 6 comma 6, they were with each other, so 6 comma 6 is fine, but 5 comma 5 is not achievable. Why? Because even if you decrease this value by once, this 5 will never be able to catch its value to 5, right? There will always be some difference. So this is not possible. So the answer for that this test case is no, right? So the code of that is very simple as well. Let me see, right? So what I did was that I just sorted these arrays, and then I checked whether the first element is equal to the last element. what this means is that in a sorted array, if the first element is equal to the last element, then all the elements are equal, right? So this is done to handle this case of ours where all the elements are equal, right? When all the elements are equal, I do not need to do anything because the stove was not turned off at any time. So that is fine. So answer is yes. Then then I just, find the frequency of all the elements. If the element is equal to the max element, then I just break the loop because it is sorted and all the elements will be greater in the right side. Or you can just continue both of them are fine. Then I increase the frequency of all the elements which are not equal to the max element, and then I just check if any of the element is present more than once. If it is present more than once, then the answer is no, otherwise the answer is yes. So this is one pretty simple implementation of this problem. So the time complexity is order of n log n because we sorted and we are using a map, and the space is order of n because we are just creating another order of n log n, right? Because of the map, right? Okay, okay. Problem C, recurrence reachability. Given two integers x and y, where x is lesser than y, we define a function f of xy, which with the following rules: f of 0 will be equal to x, f of 1 is equal to y. Then for every integer k greater than or equal to 2, you have f of k as 3 times of f of k minus 1 minus 2 times f of k minus 2. Fine. You are given two integers n and m. Your task is to find any pair of integers x comma y such that they are from 1 till n and they are different, and there exists some integer k greater than or equal to 0 such that f of k equals to m, right? So all that you need to do in this problem is that you are given some set of points x and y, right, where f of 0 is equals to x and f of 1 is equal to y, right? And you have to find whether there exists some index such that f of k becomes equal to n, right? If it is possible, then you have to return the values of x comma y that you initially choose, right? And the function f of k is 3 times of f of k minus 1 minus 2 times of f of k minus 2, right? So this is the problem. And one thing that you can see that the range of x and y, they are from 1 to 1, right? And n is given to you in this problem, right? So one thing that you can notice is that if we talk about the solution, is that if the value of m, right, that you need to find, sorry, that is given to you, and you have to tell whether there exists some pair of x comma y such that m is achievable. If this value is less than or equal to n, then what will happen? Now see, since m is less than or equal to n, you can see that f of k, this can be written as 3 times of some value minus 2 times of some value, right? If we choose the value of k as equal to 1, right, then this condition is not valid because this then k minus 1 and k minus 2 will become negative. What happens if k equals to 1? We see that f of 0 is at x and f of 1, this is equal to y, right? Now since we know that x and y both are bounded by n, right, so their value cannot be greater than n. Similarly, m is also lesser than n, right? And if you want something to be equal to m, you can just choose this value as, right, this value as 1, right? You can just choose k equals to 1, and your x can take any value, right? Any value, and your y will be equal to m, right? If this is so, if you choose this, then x can take any value, right? F of 0 will be anything, and f of 1 that we are saying equals to m. So 1 is one possible index, right? 1 is the, when we choose k equals to 1, you are able to achieve that f of k, which is f of 1, which is equal to m. right? So this is one sub problem where if n is greater than or equal to m or m is less than or equal to n, then one simple thing that you can do is just choose any value of x and you can choose y as m, right? So our answer is that if m is actually less than or equal to m, then you can return maybe let's say 1 comment, right? Any value of x is fine, so you can just return this, right? So this is one case. Now the other case that you are left with is where m is greater than n, right? This is one pretty interesting thing, right? Now you cannot get away with some clever work. You have to actually do the maths or maybe calculate something. Okay, how do you define f of k? You define f of k as 3 times of f of k minus 1 minus 2 times of f of k minus 2, right? This is your f of k. Now if you have studied designed and analysis of algorithm in your college, then you must know that this is a recursive formula and there is something called characteristic equation, right? Characteristic equation corresponding to each recursive formula. So that equation for this function will be, let's say, x square equals to 3x minus 2. So basically we just the term which has a degree of less minus 2, you can just replace it with a constant, right? They're constant values, and the corresponding of that you just keep the powers, right? Suppose this was plus 2 ahead of k minus 2, right? This k is actually plus 2 ahead of k minus 2, so you added the power 2, right? Similarly this one was plus 1 ahead of this, so you keep the power as 1 and you take this as a constant. So this is the characteristic equation, and this can be written as 3x plus 2, right? So this is the characteristic equation, and if you apply the master's formula, then you can just obtain that the function f of k is actually equal to a plus b into 2 raised to the power k, right? This is one way of deriving it, right? This is one way of saying this. If you know about characters equation and master formula, then you can directly achieve at obtain this result. But like it might not be, you might not be aware of this thing. So let's just use some other method by which you're able to derive this, right? So that is induction actually, because you can just keep on putting the values, right? You know that f of 0 is equals to x, f of 1 is equal to y, but can you write f of 2 from this equation? 3 into f of 1 minus 2 into f of 0, right? 3 into f of 1 minus 2 into f of 0, right? This is f of 2. Now f of 3 is 3 into f of 2 minus 2 into f of 1, right? This is 9y minus 2y, that is 7y minus 6x, right? Similarly, f of 4 is 3 into f of 3, which is 7y minus 6x minus 2 times of f of 2, which is 3y minus 2x. This is 21 minus 6, that is 21 minus 6 is 40, right? Sorry, it's 15, right? 15y minus, this is 8 minus 18 and plus 4, which is minus 40, right? So this is how it's going to proceed, right? Now if you see here, you can write this as uh, x plus y minus x into 2, not 2, 2 raised to the power 2 minus 1, right? Is this true? This is x minus 3, right? Right. So this can be written as x plus y minus x into 2 square minus 1. This can be written as, oh sorry, this can be written as x plus y minus x into 2 to the power 3 minus 1, right? Similarly, this can be written as x plus y minus x into 2 raised to the power 4 minus 1, right? Something like this. So, uh, so I obtained this after performing some mathematics, right? So you can notice that each of these values that are obtained from this function f, they are of the type f of k equals to some value x plus the difference of y minus x multiplied by 2 raised to the power k minus 1, right? And if you simplify this, you can obtain this, you can just obtain this result, right? A plus b into 2 raised to the power k, right? So this is one observation thing that you can just derive it, right? So this is one thing, right? Now how do you proceed forwards? Now notice that this value 2 raised to the power k minus 1, this is going to increase very rapidly, right? So since we know that the bounds on m are, right, this is up to 1e9, right, and we know this is greater than or equal to 1, then this value is 2e5 to 1e9, and this 2 raised to the power k minus 1, this will increase very large, like very rapidly. So you just need to try the values from like 1 to 30 only, 1 to 30 or 32, right? Because 2 raised to the power 32 is actually greater than 1e9. So all that you need to do is just find some values of x and y, right? Some very small, because you just need to try very small values of x and y, because this function is increasing very largely, and after some iterations this will become greater than or greater than m, right? And you know that y is greater than x, so this is actually greater, this is greater than 0, and this is greater than 0. So you just need to find at some point where f of k becomes equal to m, right? How can you do so? So since you already arrived at this result, now notice that if I write this function f of k as what, x plus y minus x into 2 raised to the power k minus 1, right? Now let me make some abbreviations here. Suppose I am denoting t as 2 raised to the power k minus 1 and this difference d as y minus x, right? So now our function f of k will look like x plus d times t, right? Because d is substituted here and t is substituted there. And we want for some values of x and b or something like that, it is going to achieve n, right? So how can I write x as? I can write x as m minus dt, right? This is one case. Also, now we can notice that since x is greater than or equal to 1, right? And x is lesser than y. And what is y? You can notice from here that y is actually x plus d, right? This is x plus d and this is less than or equal to 1. So we have one another inequality, right? So now what can we do? We can notice here, since x is greater than or equal to 1, right? Since x is greater than or equal to 1, we can write m minus dt as greater than or equal to 1. So d is actually less than or equal to m minus 1 by t. This is one result, right? This difference of y and x is less than or equal to m minus 1 by t. Now x plus d is lesser than n, right? X plus d is lesser than or equal to n. And what do we also have? We have m minus dt, right? This value, sorry, this is equal to x, right? We saw here. and we also have y less than or equal to n, right? What is y? Y is x plus d. So we can write m minus dt plus d is less than or equal to n. So can we also generate some inequality here? We can take d common, so that will leave us with t minus 1 less than or equal to n. Now we can write that d is greater than or equal to m minus n divided by t minus 1, right? So now we have two constraints on t, right? One is m minus d is actually lying in the interval. The first interval is the left boundary is m minus 1 by t, and the other one is m minus n divided by t minus 1, right? This sorry, I actually wrote them in the other order, right? This should be m minus divided by t minus 1, and this is m minus 1 divided by t. Now notice that this has to be greater than or equal to, so I have to take the seal, and this is less than or equal to, so I'll have to take the floor, right? Now I have some values of d which denotes the distances, right? So this is what, this is the difference between x and y. Now what I can do, I can just choose any of these differences in some interval, and if that forms a correct interval, then I can choose any values of x and y from that interval. What I mean by that is, so here you saw that this value, this 2 raised to power k minus 1, this will increase very rapidly. So what you have to just do is just, you have to check whether this thing, right, for some value of t, whether this forms an interval or not. Suppose if at some, let's say t equals to let's say 7, right, this value made an interval of 3 comma 4, right? Suppose in some case you had this d as 3 comma 4. So what you can just do is just choose x equals to 3, and then choose the value of y as x plus any value from this interval, right? X plus d, let's say 3. So we can choose y equals to 6. So 3 comma 6 is one fine pair, right? You can just choose this. So all what we have to do is just iterate over all the values of k, right? From 1 till, or from 2 till 30, because k equals to 0 and 2 are handled there. Because if k equals to 0, then this is not valid, because 2 raised to power 0 minus 1 will become 0, and then you will be left with f of k equals to x, and we know that m is actually greater than n, right? So f of, and since x is less than or equal to n, they can never be equal. Similarly, if k equals to 1, then you will have 2 minus 1, right? So 2 minus 1 will be 1, so this will be x plus y minus x, right? And that will leave you with y. And since y is lesser than n, and m is actually greater than that, so that is not fine. So you will have to choose x greater than or equal to 2, right? So you can just iterate from k equals to 2 till 30 or 32, something like that, and you just see whether this value m minus n by t and m minus 1 by t minus 1, right, whether they form an interval or not. This is t minus 1, right? Whether they form an interval or not, by check, how do you check whether they form an interval or not, right? If I denote this left value as l and the right value is r, then we need l less than or equal to r, right? If this condition is true, then they form an interval. Then this value d is obtained. We can just choose x as, let's say we can just choose x as l, and we'll choose y as l plus d, right? Whatever this value, anything in this range, that will work fine. So this problem was all about maths. You just need to know how do you deal with the recursive formulas and stuff. So here, if m is equal to 1, we can just print m 1 and 2. This is fine, because uh, you can just choose the value of x as 1 and then y as 2. Then your m will become, so what I mean by that is, suppose your value of m is 1, right? And your recursive function is f of 0 equals to x, and f of y, sorry, f of 1 equals to y, right? So you can just put the value of x as 1 and then y as 2, right? So your f of 0 will be 1 and f of 1 will be 2. That is fine. You can just, I could have just handled it here as well, that is fine. I explained that if m is less than or equal to n, you can just choose any value of x, right? And you can just choose any, sorry, the y value will be n, right? That will be fixed. Now what you can do, since told you that we are iterating on the values of k, right? From 2 till 32 or something like that. So I have the power, so this is 2 raised to the power 2, right? So p denotes the value of 2 raised to the power k, right? Now, okay, let me simplify this. So now your t will be equal to p minus 1, right? So this is 2 raised to the power k minus 1. So what is the value L? L is nothing but m minus n divided by t minus 1, the floor value of this thing, right? So m minus n, right? So we want ceil of m minus n divided by t minus 1, right? And since you know that t is equal to p minus 1, you will have p minus 2. And how do you take the floor of two things? You just do, in order to take the floor, sorry, ceil, this is nothing but m minus n plus t minus 1 minus 1 divided by t minus 1, right? Ceil of a by b is a plus b minus 1 by b, right? You can just expand this formula, put the value of t, you will obtain this result. And similarly, r is m minus 1 divided by p minus 1, right? And you check, why did I write file? I can just do if, right? If the value is l is less than or equal to r, then your value of x will be, so since you obtain your value of d, right, you can just choose d from anything from this range. Your value of x is m minus dt, right? You can just put value of x is m minus, I'll choose anything from this interval l to r, right? So I can just choose l, and t is what? T minus 1, right? So I just put t minus 1, and the value of y will be x plus d, or d is replaced by l, so that is fine. So x is done and y is done. Then you can just print x and y, and you can just multiply your p by 2, right? If you do not find anything from this pair, then you can just return minus 1, because that is all that we need to check. We have covered all the possible values of uh, vertices where the value of m could have been obtained, right? So this was the code for problem C. Thank you. Moving to problem D, constrained chopping. Alice and Bob are playing with an array A of 10 integers. The rules of game are as follows. Let this denote the current length of the array. If this value is lesser, if the size of the array is lesser than 2, then the game terminates immediately. Otherwise, Alice must choose an integer index I such that I is greater than 1 and it is lesser than the size of the array. Then Bob must choose one of the following must perform one of the following these two actions. Delete all elements at the indices 1, 2 till I, or he can delete all the elements at the indices I plus 1 till the size, right? After Bob's choice, the remaining elements are re-indexed starting from 1, obviously. After the game terminates, Elias's score is defined as the largest element remaining from the array. Note that in the game is only allowed to end when there are no more than two elements remaining in the array. Elias wants to maximize his score, and Bob wants to minimize it. So in the optimal play, what will be the Elias score? That is what we are have to find. The test cases are pretty normal. N is 2a5, so they are expecting an order of n or order of n log n solution, right? So let's just see what this problem is saying. So in this problem, you are given an array, right, which consists of multiple elements, right? So in each step, what is going to happen is that suppose Alice chooses some index, right? Let me index them. Suppose this was 1, 2, 3, 4, 5, 6, and 7, right? At some point, Alice will choose some index, right? So suppose she choose index equals to 4. right? And that this index should not be an extreme index, right? It should not be 1 and it should not be equal to 7, right? So what will happen now, that Bob has now a choice of removing either the prefix or the suffix of this index, right? So either he can remove this part or he can remove this part, right? Right. So the two choices, Bob's array can look like, let me draw it like this. Suppose if Bob chooses to remove the left part, then your final array will be consisting of 5, 6 and 7 only. On the other hand, if Bob chooses to remove the right hand side, then your array will have 1, 2 and 3, right? So this is the problem where at each step Alice will choose some index, then Bob will have a choice of either removing all the elements from the left or all the elements from the right, right? And then the game will continue from these arrays. So what they're told to do is that, suppose at this point, if Alice has only one valid choice, right? He can only choose this value 6 because she cannot choose the extreme values. She cannot choose this and she cannot choose this. So what will happen if Alice chooses this? There are two possible cases. Either Bob will remove 5 or he will either Bob will remove 5 and 6 or he will remove 6 and 7, right? In these cases the final array will either be 5 or it will be 7. Similarly here there are two possible answers, either it will be 1 or it will be 3, right? So there are multiple choices, there will be a game tree of these choices. So what you're told to do is that you have to maximize this score, right? If Elias and Bob both play optimally, then what will be the final score or the final remaining element of your array, right? So one option that you can make is that, suppose if your array had only, suppose, three integers, right? A, B and C, right? Then the only choice for Elias was to remove this element, right? And Bob will either have A or he will have C, right? So you will have A or you will have C as your final result, right? So there was no actual choice available to Alice, right? Now suppose uh, if I model this problem like, I'll denote all the elements which are greater than or equal to some value x as 1 and all the elements which are lesser than x as zeros, right? Then I can transform my given array into a binary string, right, which will consist of ones and zeros. 1 1 1 0 0, right? Something like this. So your array will convert to a binary string. And what will each one denote? Each one will denote that this number was greater than or equal to the given number that you fixed, right? So for each x, you will have a different array or multiple arrays, doesn't really matter. And each zero will denote that this element was actually lesser. Now you do not need to care about the elements which are, you know, you do not need to compare these two zeros, right? Because both of them are zeros, so they do not really matter. And similarly, both of them are, if both of them are ones, then it doesn't really matter. And now my problem becomes that if you Alice and Bob both will play on this given string, then is it possible for us to get at least a single one or multiple ones in your final array, right? So what I mean by that is, suppose at each step, what they can do, suppose you have the array as, or maybe the binary string as 1 0 1 1 0, right? And if Alice chooses to have this, choose this is this index, then either Bob can remove this part, sorry, this part, or he can remove this part, right? So your final array, if Bob removes this part, then he'll have 1 and 0, right? And now you can see carefully that he cannot remove anything and the string is consisting of a single one. So this state is winning for Alice. right? So this is one case. If Bob had removed suppose the right hand side of the right hand side of this array, then you will have what, 1 and 0 here also. So this is also winning for allies. Winning for allies means that if you choose some x and you obtain this array or maybe a string, a binary string, and then Bob and allies will keep playing on this binary string, and the resultant, if that resultant string or the reduced string which has a length of 1 or 2, right, because this is where the game ends, if that contains a single one, then this x is achievable, right? This is what it means, right? So what we are trying to do is that if we are able to, achieve a single one or multiple ones in the final string, then this x is achievable, right? So the answer for that will be this value. Suppose if for 5 this was the answer, then 5 is achievable. So what we are trying to do is that we are trying to maximize our x such that our function, let's call it f of x, which is this only, right? You feed in the value of x, it generates you the string, and it tells you whether in the final array you can have a single one or not, right? Such that f of x becomes true, right? If f of x becomes true, then then what we are told to do is that we have to maximize this value x, right? That will be our answer. So in this case, you can notice that if your array or your string has multiple ones, right? If you have many ones in your array, then the chance of you ending up with a one is more, right? As compared to an array having a less number of ones, right? Because in each step you're going to choose some index and remove some part, and then the game will continue. But if you have more ones, then you have more chances of getting a one, right? So this gives us a hint of binary search, right? Where we should binary search on the value x such that f of x is equals to true, right? So we'll binary search on that, right? So what we'll do is just that we'll fix our lower bound as this, L as 1 and R as suppose some very large value, right? Or whatever, let's say N, which is given in the problem. And then we'll binary search and we'll find the most optimal or the most rightmost point of our array such that f of your answer is true. And then you can just return your answer. This is what you have to do. So all that's left to do is to find this function which tells us whether for some given number that you have, the string is good or not, right? Or maybe that whenever Alice and Bob will perform their operations or maybe play their game, then finally get one or not, right? So to do that, you have to notice one thing, right? Your winning state, right? It can be of very less number of types, right? Because suppose your string that you feed, if its length was lesser than let's say 3, right? Then the only winning states were either you had a single one, right, in the left in your array, or you had 0 1, or you could have 1 0, or you can have double ones, right? If at the end you have any of these four possibilities, right, then Alice is winning, right? This is the case, right? If your string had some length lesser than 3, but if your string had some length which is greater than or equal to 3, then you will be able to find some point where you will partition your array, right? Now suppose some magic happened and you were able to find the answer for the left and the right parts, right? Now, if Alice is now wondering whether should she split her array, split, split her array at this index, at this index, right? When is it optimal for Alice to split her array at this index? What I mean by that is she should either perform this operation or she should perform this operation, right? This is what she had to find. Now, suppose if you are able to find the answer for these two arrays somehow, then can you tell me what should be the condition where when she should split, right? Suppose if she split it in this way and then this was not winning for Li, this was not winning for Bob, right? This was losing for Bob. Bob loses, right? If this was losing for Bob, then what he could have done, that Bob would have deleted this part of the array, right? Similarly, if this was losing for Bob, then Bob would have deleted this part of the array. Sorry, if this was losing, then he would have deleted this part, and if this was losing, he would have deleted this part, right? So the only case when Alice wins is that when both of the right hand sides were losing for Bob, right? This was losing for Bob and this was also losing for Bob, because in any case, if this was losing, even if Bob deletes this part, this will also be losing for Bob, right? So Alice will win only if this is winning for Alice in both the left hand sides and the right hand sides, right? By winning and losing, I mean that if they perform this, they perform all their operations or this suffix or this prefix, then they will remain with a single one or double ones or 0 1 or 1 0, something like that, right? So this is the case. So now we were talking about when the value or the size of the array was greater than or equal to 3. Now notice here that since we know in order for Elias to win, she will have both winning sides on her side. Now you saw here that each winning side will consist of only these four possibilities, right? Now suppose if you have some array which is winning for Alice, suppose it has 5 or 6 elements, right? Then it can be winning for Alice if it constitutes of only winning states, right? So suppose this was 0 1, this was 1 0, and this was 1 1, right? This can be winning for Alice if and only if it constitutes of winning arrays, right? So that is the case. So what this tells us is that for each index, right? For each index, let's say I, what we have to do is that we have two possibilities, right? One possibility is that you take it as a single element, right? It will be a single element, single element, right? And that is what a single one. Or you can take this or pair this with some other element. So the case will be that you will have 0 1 1 0 and 1 1, right? So these are the two states possible for each array. Now suppose if this index is true, then either we are going to pair it with some previous index or we will take this singly. So what this tells us is that each winning array or each array can be divided into multiple smaller winning arrays, right? And since we know that each index has its contribution with just its previous index or just this index or just this index, right? So we can divide this problem into smaller sub problems, right? What we can tell is that suppose if we want to know whether this prefix is winning or not for Li's, then what she can just do is either she can just pair this element with this element or keep this singleton, and this part, this previous part, will be independent. So now we see, since suppose if you have these arrays, then if this element I and this is I minus 1, then we can notice this part becomes independent from 0 to I minus 2. So this tells us that we should apply some dp on it, where dp of I will tell us what? dp of I will tell us whether prefix 0 to I is winning for allies or not. So this will be a boolean value, either it will be 1 or 0, right? So this is what we have to do. So this is how we denoted our dp. So what we're trying to do is that we'll just binary search on the value x, which is going to be their maximum value that we're trying to maximize, and we will, for each value x, we are trying to find whether dp of n, right, when the total array, right, dp of n is true or not. If it is true, then this value x that you pass to your function is actually true, and then you are able to achieve the value x. Achievable. Otherwise it is not achievable, right? So in sum, what we're trying to do is just trying to partition our array into multiple pairs, right? So suppose 0 1 and then 1 zeros, or you can have a single one, or let's say 1 1, something like that, right? We're going to have multiple such pairs, and each pair will note a single winning argument, right? So how can we do so? How can we, so all that's left for us is to write the db transitions, right? So how can we write db transitions? You have two possibilities, right? Either at some index you can choose that this index will remain singleton, right? You have some index I, and it has two possibilities. The possibility one is it will remain singleton, right? So this will form a singleton array, right, of size 1, subarray of size 1. So in this case, what will happen is that you will have I minus 1, right? So since this is remaining some single, this is the point which allies will choose, right? And all the previous ones from 0 till I minus 2 will act as an independent thing, right? And since we want this element to be single, so the value, that is the string value at this point, should be 1, right? Because a singleton means that value should be 1, and when it is 1, 1 denotes that this value is greater than x or equal to x, and 0 denotes that this value is lesser than x. So in order to have this value as 1, we need this value to be greater than x. Then I minus 1 will be acting as a border, right? So I minus 1 will be deleted, and then 0 to dp, then 0 to I minus 2 will be acting as a independent subproblem. So in order to update dpi, you will have dp of I minus 2, and you will take this bitwise AND with whether s of I is actually equal to 1 or not. So this is one case, right? Another case could be that index I is going to be paired with other element, right? So let me write this as index I is paired. So index I is paired with element I minus 1, right? Both of them will be paired. And then you'll have I minus 2 and I minus 3s, something like this. So since both of them are actually paired, this element I minus 2 will act as a separator, right? And 0 till I minus 3, this will be your dp, because this is independent part. And now since these two are together, you will have both of them should be equal to 1, because this has to be a valid string. Then you can update your dp as dp of I minus 3, because this element doesn't really matter, because this is what will be chosen by allies, and that will be deleted. And dp of I minus 3, and you will have s of I equal to s of I plus s of I minus 1 and s of I equals to 1, right? So this is how you will update your dp, and in the end you can just check whether dp of n is equal to 1 or not, right? So this is the case. So what we did in this problem is that we noticed that each part of the array is actually dependent upon the smaller subparts, right? Each winning state consists of either a single element or double elements, right? So in order to constitute an array which is winning, we need to consider only the left border of that, right? So if some point is winning for allies, that is winning only if both right part and the left part are winning for them, right? We saw that. And in the case where we saw that if the value of the size of the array is greater than or equal to 3, then we can just pair our current element with the previous element, or we can leave the one element as singleton. Then from 0 till I minus 2, that will be acting as an independent part, right? And the other transition is similar, that if this element is singleton, then the I minus 1 will be acting as a will be acting as the separator, right? We saw here. And we can just update our dps, and in the end we can just return dp of n, right? So let me show you the code. So okay, first of all, we were binary search. The first approach of ours was that we need to binary search on the largest value of n, which returns as the value of dp of n as 1, right? So we'll binary search on that. Answer will store our final answer. Then I'll just call our checker function that will return me a boolean value either of 1 or 0, right? If it is 1, then I'll set my answer to mid, right? And I'll update my left point to mid plus 1. In the other case, I'll update to r minus 1. Then in the checker function, what is happening? I'm just creating a dp. Then in the case where dp dot front, that the 0th value, if we consider only the first prefix, then only the single element, then a single element, in order to, we cannot pair it, so that element has to be greater than or equal to cur, right? That element has to be greater than or equal to the current element x that we have uh, that we are binary searching for. So this is first case. And notice that this problem had the constraints of n greater than or equal to 1, so you have to handle them separately for each x. So if n is 1, you just return dp dot back. Then you can update your dp dot 1 as that you want for. So if we see here that if we want to pair something at these two indices, right? Then both of them should be greater than or equal to 1, right? So both of them have to be 1 1. So we can see that minimum of them should be greater than or equal to cur, right? Sorry, this one. Okay, so sorry, this not this one. Actually, if you want to, in the in this size, suppose if you have two elements, if your size was only 2, then 0 1 and 1 0 both are winning, and 1 1, of course, this is one of the winning states. Then you can notice that since these three are winning, you just want to avoid a case of 0 0, right? So you want the maximum of both of them, right? This value v of 0 and v of 1, at least one of them should be greater than or equal to your given value there, right? So that is what you want. This is them. Then if n is 2, then you just return dp dot back. For the case where you have n equals to 3, you can notice that if you have, suppose, this and this, right? If you have a, b and c, then the only splitting point Alice has is b, and if she wants to win, then both of them have to be equal to 1, right? So both a and c have to be equal to 1. So in order to for it to have equal to 1, both of them should be greater than or equal to curve. So the minimum value of them should be greater than or equal to curve. Then you can just return dp dot back. Then in the case from 3 to n, you can just iterate that, and then you can just consider both of the possibilities. Now we can see the transitions here. The first transition is this one, where we see that if I is paired with the previous element, then dp I minus c must be true, and the previous element and the current element, both of them have to be greater than or equal to 1, right? This is the first case. The second case is where you are treating you're treating this element as a singleton element. Then what can happen? You just need this element to be greater than or equal to the current element, that the current element x that you are binding searching on, and then I minus 1 is acting as a separator, so dp I minus 2 must be true, right? So that is that, and then you update your dpi's x or equal to okay, and then you just return dp dot back, right? And in the end, you will have your answer. I hope it's clear. It was a bit much trickier. If you did not make the observation of, you know, having that if you just need to pair the current element with the previous element, or you just have to check this element as independently, then you can just keep running the recursion and from like, right? What I mean by that is, suppose if you did not make this observation that in order to check whether L2R is good or not, what you could have done is that you would have fixed some element x in this range, and then you would call the recursion from L to x minus 1 and from x plus 1 to r, right? But it doesn't really matter. In order for a state to be winning, we saw that it is comprising of only states consisting of two elements, right? So for this state to be winning, we do not want to look any further. We just need to pair it this with the previous element, or we do not need to pair it with anything, right? This one is also fine, right? In order to pair that, Alice must remove this element. So this is acting as separator, or suppose as a wall, right? And then this part must be independently true. And similarly, in this case, this part must be independently true, right? I hope it's clear.